Hello, this is 9.3, constant rate of change and slope. And what I need you to do is copy what you see on your screen, divide your paper into 4 sections, and press pause to do so. And when you're ready to continue, press play. Please pause now. On the top left of your notes, we have constant rate of change, which is also known as the slope, and that's the change in y over the change in x. This red bar here is a division bar. So pause the videos to copy this down, and when you're ready to continue, press play. Please pause now. So now I want you to write here what you see on your screen. This is the constant rate of change, or the slope in graphs. So here we have on the first upper left, we have a positive slope, and that's when a line starting on your lower left of the graph, when it increases going towards the right, from left to right it goes up, then we say there's a positive slope or a positive constant rate of change. And on this one here, for this graph, on this line, if you start on the left side of your coordinate plane and you go to the right, and notice it decreases. If the line's going in this direction, we say it's a negative slope or a negative constant rate of change. And here on this graph right here, on the line, if it's going straight across horizontal, we say that it has a 0 slope. And on the last one here on this coordinate plane, when this line here, when it's vertical, then we say that it's undefined. Pause the video if you need to copy this down, and then press play when you're ready to continue. Please pause now. Okay, on the top right of your notes, I want you to copy this table that you see for problem number 1, and we're going to find the constant rate of change. Now, the reason why we don't say slope in this case is because there are 2 different quantities here for our x and our y values. So our y values are in feet, and our x values are in seconds. So here we would say find the constant rate of change. Now, what we're going to do here is first I want to label the x row and the y row. So this here, the top row is always your x, the bottom row is always your y. Okay, and what we're going to do first is to find the change in the y values. So if you look at 7, and then it decreases to 6, which then decreases to 5, which then decreases to 4, that is decreasing by 1. So I'm going to write little minus 1s. Okay, and then we're going to look at the change in the x's. So we start at 7, and then it's going to go to 9. So that's going up to 9, then it goes up to 11, and then it goes up to 13. So that is increasing by 2s. Okay, so according to this table, the constant rate of change is going to be our -1 over 2. So I'm going to write that here with units, so -1 foot over 2 seconds, which then simplifies to -1/2 a foot per second. Okay, let's box that. Now, in the textbook, it may say interpret its meaning, the meaning of this constant rate of change. So how we would interpret it, we would say is every second, the distance drops a foot, 1/2 a foot. So in order to save space, this is how I wrote it. Every second, it drops 1/2 a foot. And then we box that answer. That's our interpretation. Okay, for problem 2, I want you to copy this graph as you see it on your screen. Pause the video, and when you're ready to continue, press play. Please pause now. Okay, so here we're going to talk about finding the constant rate of change using a graph. So on the graph here, we have 2 points. We have 414 and 26. And the 2 quantities that we're looking at are the number of cookies versus the cups of flour remaining. Okay, so what we're going to do is we're going to find the constant rate of change, and we're going to find the change in the y's over the change in the x's. And if you remember, the x is the first coordinate and the y is the second. So above each ordered pair, I'm going to label them x and y. Okay, so what we're going to do first is we're going to find the change in the y's. Those always go on top. So the y here, we're going to have 14 minus 6. Okay, and that's how we find the change, as we subtract them. And then for the x values, since we started with this 14, we have to then start with the 4 that goes with the 14. We can't start with the 20. So we're going to have to subtract 4 minus 20. So we're going to put that in the denominator. Okay, so y's always go on top. And now we simplify it. So 14 minus 6, we have 8. And then 4 minus 20 is negative 16. So then this is going to simplify to negative 1/2. Okay, now remember with our labeling that y refers to the cups of flour, and then the x refers to the number of cookies. So this is actually 1/2 a cup of flour per cookie. So I'm going to write the constant rate of change like that. And then if we were asked to interpret its meaning, then we would say for every cookie, 1/2 a cup of flour is used. So I'm going to abbreviate that a little bit. Every cookie uses 1/2 a cup of flour so that it all fits in there. Pause the video if you need to copy everything down before we continue. Okay, so now on the lower left section of your notes, I want you to copy what you see on your screen. Make sure you keep several lines here, like 3 lines in between problems 3 and 4. Pause the video to do so, and when you're ready to continue, press play. Please pause now. All right, so here we're going to be talking about the slope, which is the steepness of a line, and the slope is the difference in y's over the difference in x's. And this is very much like constant rate of change, but now we're looking at ordered pairs. Okay, so remember, when we have a positive slope, that means our number is positive, then that means our line's going to be going up this way. Okay, if we have a negative slope, our line would be tilted this way in this direction. A 0 slope would be across, and an undefined slope would be a vertical line. And now we're going to find the slope of a line that goes through these 2 ordered pairs. So I often tell my kids to remember the saying, let the y's rise. So you can write this next to the problem. So with this saying, what that means is, what we're going to do is we're going to look at the y coordinates of each ordered pair, and we're going to circle those. We're going to draw an arrow going up because they're going to go in our numerator. Okay, so here we're going to put 7 and 1, and we want to subtract them, so it's 7 minus 1. And then in our denominator, our x's are going to go in there. And since we started with this ordered pair, we have to start with, for the x's, we also have to start with this ordered pair. So we're going to start with this 3, and we put 3 first, and then 5 second, and then we subtract them again. And then we're going to simplify this fraction, and that's our slope. So 7 minus 1 is 6. 3 minus 5 is negative 2. And sometimes it's a whole number, sometimes it's a fraction. In this case, it's a whole number. Negative 3 is our slope. Okay. Always simplify your answers as much as possible. So now let's go ahead and take a look at problem 4. Okay, again, we're going to let the y's rise. So we're going to circle our y coordinates, okay? And then in our fraction here, we're going to put the y values. So I'm going to start with negative 8, and you're going to subtract the 1 from it. And then in the denominator, we're going to have 3, and we're going to subtract the other 3 from it, the 2 x's. So now this is negative 9 over 0, which means then it's going to be undefined. Anytime you have a 0 in the denominator, that's undefined. Okay, now it's a good time for our movie clue. So for our movie clue, if you're listening, I want you to draw a picture of a mountain on the left side here of number 4. That's going to be like the slope of the mountain will be on the side, but just draw a mountain. Okay, now let's do another problem. So let's say we have these 2 ordered pairs, and we're trying to find the slope of the line that goes through these 2 coordinates. So now what we're going to do again, circle the y values, okay? Let the y's rise, so that means they go in the numerator. And we're going to put 7 here, 2 here, we subtract them. And then in our denominator are going to be our x values. So we have 4 and 6, and we subtract those. And so then we're going to have 5 over negative 10. And then we simplify it, and the negative we're just going to bring to the top. So this has a slope of negative 1/2. And that's all for your notes. Thank you very much. Bye-bye.